convenient way of representing such type of data is to use a data frame. And as we progress in our data analysis journey, whenever we receive data in Excel or CSV or any other tabular form of data, in most cases we import them into our environment as what? As data frame, because most practical data contain varying columns of different nature, isn't it? So there shouldn't be any reason why we should import our data as a matrix or anything, isn't it? Because matrix require that the information are of the same format, isn't it? So, and that's why this is the bedrock of any data analysis task in R. And how do you the syntax for creating a data frame in R is using this function data.frame, all in small letters. Yeah, I think that this is where, or this was where we stopped last week, isn't it? So we'll just continue from there. The syntax for creating a data frame is to use this function data.frame, and then you have the various columns that you want to, yeah. For example, in this example, the first column should take the header of what? ID. And then we have how many elements? 2, because it's a 1 to 2. And any other element that comes thereafter should also have the same length, isn't it? Because here we have 2 rows, isn't it? It means for the ID column we have 1 and 2. So we shouldn't come to name and then we see 3 names: James, Amy, and Patrick, for example. If we are to have Patrick here, then we have to make the ID to be what? 1, 2, 3. Okay? And then, so this is basically how to do that. So this is a very clear example.
Recording in progress.
So this is a very clear example of how to create a data frame in R, where we use the data.frame function. And we supplied in as a first column, number 1 to 2. Our second column named name, having 2 info data, James and Iman, and finally,
okay.
And then age, having 42 and for 18. And if you print out this data frame, this is the visual look of it here, isn't it? 1, 2 for ID, James, Amy for name, and then 42, 18 for age. This 1, 2 is just the natural index that comes with any code in R, isn't it? And just like we mentioned, you can access any element of a data frame either using the traditional double square bracket, or a more elegant method is to use the what? The $sign. So they do the same thing. So this is an example. We have this data frame. It is shown here. And then we want to access the second what? The second element, isn't it? And if the second element here is the entire second row here, isn't it? So we have EMI and 18, isn't it? Sorry, the second column, isn't it? Here, James and EMI. So if we said, because they are column wise, each column is an entity, isn't it? Because if you say row, it carries everything in each column. So if you say 2 here, it gives you the second column. If you put 1, it gives you the first column. And an alternative method to using the 2 is to simply specify the name of the column. You understand? We know that this is the first column, this is the second. if you simply access using the double square bracket and you call 1, it gives you this. If you use 2, it gives you this. If you use 3, it gives you this. But if you want to simply specify the column, you can simply specify the name of the column, just like we do here. So you have X double square bracket, then the name column, and it gives you the what? The names that we have there. So just like I mentioned, an alternative method to using the double square bracket is to use the $sign. And if you use R, as soon as you even call the $sign, it enlists all the available columns for you. So you just choose. So using a single square bracket will return a data frame that consists of the specified column, we can also access the element of a data frame similar to a matrix by specifying the rows and the columns, isn't it? So we can get the rows and the columns. I hope we know the difference between using the single bracket and the double square bracket. For the single bracket, it gives you including the header, isn't it? But for the double square bracket, it gives you only the elements of that column. And since it's also a tabular data that has rows and columns, if you want to specify a particular element, you can access that using its index, and the index will now be the row and the column, isn't it? For example, here you have this data frame, and you want to access the element in the second row of the third column, isn't it? The second row of the third column. So this is the second row, and then this is column 1, column 2, column 3. And if you do that, it returns what? It returns 18 to you. If you want to return, let's say, James, it will be X what? Double square bracket, and then what? Row 1, column what? Column 2. Yes. So we can also use the names of the columns when indexing. For example, instead of saying row 2, column 1, we can say row 2 of the name column. The first element is the row, and then the third column is the second element is the column. So you can also explicitly specify the name of the column as opposed to the number of the column, and it will give you exactly the same thing. Yes, it's clear. So I have this example. I have a data frame named X that has a column for products containing banana, apple, and orange, and another column for price containing 5.99, 2.49, and what? And 3.0.
No. Okay.
Okay.
Somebody asked from the
buy it.
Okay. I hope they can now see the entire screen. What's happening? Pause. Aina. Let me just stop sharing and then share again, and then share the entire screen. I believe it should be visible now. Okay. So this is a very hurried quiz. We have a data frame that has, let me see, if I should draw this, it should be, we have product here, and that will contain banana, apple, and what? And orange. And then for the second column we have what?
price.
We have price, and then we have 5.99, 2.44, and then 3.0, into 3 point something. It's 2. then 5. Okay. So we now said fill in the blanks to output the price of apple. What's the price of apple? That's 3.3 point. Okay, this is 2.49. So if I want to access this guy, what will I do? So what should be here?
X.
X is the name of the data frame, isn't it?
Yes.
So from this data frame, I'm using the $sign to access what?
Price.
To access the product, isn't it? And the product has how many elements? 3. So what will be here?
2.
You know, this will come as a vector, isn't it?
Yes.
And you know vectors start indexing from 1, 2, 3. So and then here will be what? Here will be 2. It's clear, huh? If you use a $sign to access a column of any data frame, the entirety of what index comes to you as a what? As a vector. And you've learned how to manipulate vectors. If you want to get the first element, what do? You use 1. If you want to get the second, you use 2. And if you want to get the third, you use 3. It's clear, huh? So you can add a new column to a data frame by simply assigning it to a vector of values. So you have created a data frame that has 2 columns, and you want to add another column. Let's say for this, we want to add country, isn't it? This is what we have earlier. We have ID 1, 2, names, James, email, and then age is what? That's what we have here. Go. We have a data frame that has ID 1, 2. The name is James email, and then the age is what? 42 and 18. So you can be able to add this. You can be able to add this particular new column here by simply calling the data frame and assigning. Even though the column is not there, but you, in this case, you're not indexing, you're assigning, isn't it? So just saying assign this column, assign this vector to a new column X $sign country, isn't it? And then if you print the data frame, you see that you have the original columns together with the newly added column. It's clear? Go. If I want to index Italy, Yusuf, how will I do that? If I want to print out Italy, it will be, first of all, it's simple. Italy is in what column? It's in the country column, isn't it? And you can index the country column. How do you do that? You call the data frame. The data frame is what? It's what? It's X. Then what? $sign. What? Country. $sign country. Isn't it? And then you open bracket, double square bracket, just one single bracket, and you use it. And that's what? 2. Just like we have it here, isn't it? You get the data frame, $sign, the name of the column, then single bracket to index, isn't it? To get the column. So we can also filter the rules based on a condition, similar to a matrix. Gradually. We can now use a condition to be able to pick out whatever we want to pick out from a particular data frame. Let's say we have this data frame. What's it? It has 1, 2 for the ID. The name is what? Is what? James email, and then age is 42 or 3, isn't it? Let me expand this. Let me expand this particular. Clearly. Well, we're still online, right? Good. Let me just expand this to to 4 names, isn't it? And then the age should be.
Yeah, that's one.
Sorry? Why?
I don't know. When you discarded it, that's when you discarded.
No. It's complete. It doesn't matter. I'm duplicating. Okay. I have a data frame that has ID 1 to 4. The name is James, Emai, Sani, and Dauda. The age is 42, 18, 35, and 23. Yep. Let me comment this first, and then print out the data frame. Okay, this is what I have here. Okay, you have a data frame that has 4 rows and 3 columns. Please, for every example I have, imagine you have 1,000 rows and 50 columns. Whatever we do is the same thing that applies to any other size of data, isn't it? So but we cannot handle the such number here for teaching, isn't it? So whatever small example we do, imagine that you have many. And to do that is not wahala, but you just come and increase here and then populate accordingly. So let's say here, no, I don't want this particular. So here we have this data frame, and when we want to select all the rows that have the age column greater than 21, isn't it? Please observe this place. What are we doing here? We are indexing. This is our data frame, isn't it? And then we are indexing what? We are indexing the data frame, isn't it? And remember, if you want to index a data frame, it has rows and columns. What do? You supply in the first number is the row, and the second number is the column separated by comma. You know how to do that, isn't it? If you want to get Italy, you go to the second row, third column, for example, or if you want to. But in this case, I want to do something different. I don't want to index a specific element. I want to sieve out rows based on a condition. And I want you to take this as an example. Imagine that you have 1,000 rows and you want to sieve out only the rows that have their age to be more than 21. So the condition will be where? Will be at the row, isn't it? Isn't it? At the row. No, I mean the condition will be at the row because you want to get all the rows. If I want to get the second row, what do? If I want to get the second row, third column, I'll do what? 2, what? 3. If I want to get the first row, all the columns. Second row, all the columns, 2, and then I keep quiet. Right? If you refuse to put it, like we mentioned last week, it will do everything. So this time around, I don't want to get the third third row, or the second row, or the fifth row. I want to get all the rows based on a condition, isn't it? And the condition says that, what's this? For every row, check the age column. Is the number there more than 21? You understand? Understand? I'm going to give classwork now because this, this one, if you don't understand this one, online you're going nowhere. You must you must understand this. We have a data frame and we want to index some related rows based on what we want, isn't it? And this is an example that says, give me all the rows for a row, check the rows, and for that row, check the column and see that it is more than 21, isn't it? And then comma, nothing. It means I want all the columns of that what? Of that row, isn't it? So just like I have here now. Let me go back to this. So if I do this now, if I uncomment this, what happens? If I run this, what am I saying? If I run this code now, you're saying check each row, each one after the other. It start with the first one. But if you check the row, what do? You check the age column. Is it more than 21? If it is more than 21, what do? You return the row together with all the columns, isn't it? You do that for the second, for the third, and for the fifth. So if you run this one, what happens? It returns. It will exclude number 2 and print row 1, row 3, and row what? And row 4. Is that okay? Is that okay? No, classwork. If I want to print only the names of, if I want to print only the names of the candidates that are more than 21, what do I do? Age.
Replace age with name sheet.
No, think very well. I have a data frame and I want to check the rows and see that the age is more than 21. If it is indeed more than 21, don't return every column. Return only what? Only the name. I only want to see James, Sani, and Dauda. I want you to return only the names of the candidates whose age is more than 21. Where?
Print X. No, first X.
Okay, here.
Yes. No.
Here.
X. Then dollar sign. No, not the one inside.
Okay.
X dollar sign.
Check very well. Look at it now. I said if you run this one, what's it doing? Let me run the data. Let me call the data frame first. It's printing everything, but I now said I want only the rows whose age is more than 21. But in that case, look at this place. Me asking, what's here? What is in this place? Annotate. What is in this place? It's nothing, isn't it? What does that mean? It print all for every row, print all the columns, isn't it? So if I now come to this place and say, I say 2, for example, I will say check the rows. Check the rows. If the age is more than 21, print only the second column, isn't it? Which is what? Which is names. So if you do that, you are going to have what? You are going to have only James, Sani, and what? And Dauda. Is that clear? What if you put the names here? Let me delete this. What if, as opposed to putting 2 here, you put the name of the column that you want? It also gives you the same thing, isn't it? Just like we did for. So in indexing, you can either use the index of the column or row or the number, isn't it? Let me add one name here. Let me see. Age, isn't it? 5, no? If I run this now, what happens? If I want to add, let me say I want to add another column for gender. How will I do that? Doctor, I want to add another column for gender here. Programmatically, I don't want to come here. I want to come here and just write a code that would add another column to this data frame X, right? This is it. It has ID, name, and what? And age. Go. I want to add another column to it that called gender, isn't it? So what will that be? X $sign. So far we have only ID, name, and age, but we want to add another one. So we call it what? Gender. What do you want to keep there? Equals to what? Then a vector containing, who's the first guy? Anas is a male. Then, okay, they're all male, right? Emma is a female, isn't it? Then who again? M. F. Then who again? M again. And then M again. Isn't it? And if you call X now, if you call X now, you see that we have a column for ID, a column for name, and a column for age, and a column for gender. Like I always emphasize, assume that you have 1 million rows, isn't it? Or 10,000, isn't it? Whatever you do programmatically is the same thing, isn't it? Now I want to print if you are a male, if you are less than 30, this at least I have that has 1 million entries, right? And I'll ask you, Mr. Mohammed, please, I want you to extract all the candidates that are less than 30 years, and all the female. The female, whether you are 30 or not, isn't it? I want you to be part of the list. And then any other person, if you are less than 30 years, print it out. Who will do that for us? Do you get the question? From this data frame, extract the names, extract all the rows of the candidates that are less than 30 or are females. So irregardless of who you are, if you are less than 30, we are going to what? We are going to print out your name. And even if you are more than 30, if you are a female, what do? We what? We still, so what will happen here? Anybody, please, let's go on. The data scientists, let's think now and please, let's talk. Just look at it like a friendly language. Okay, what do we do? X because that's the entry point. That's the entire data frame, isn't it? X what? Dollar sign what?
H.
Okay, I'm listening. No, I'm just typing what you said. Mm-hmm.
Class continue.
You want to index now? No, I don't want you to get any if statement. I want it in one line of code. The code we ran earlier, here is this. Yeah? So you can just modify something like this, isn't it? What will happen? Let's do it here. So we said X, because that's the entire data frame, isn't it? We now said X, because the age is what we want to check, isn't it? Age is less than 30. If we remove this guy, it will print. It will not print that female, isn't it? Because she is what? She is 35, isn't it? If I run this now, it will print only James and Dauda, and it will ignore. So you have to come here and modify the code so that it's either you are less than 30 or you are a female. So what do we do?
Say F.
So I had the pipe symbol, right? Sure, that's what you call it. Pipe. The pipe symbol, or what? What do you want to index? The gender. How do you get the gender? X dollar sign gender, isn't it? That's where you get the vector of the gender, isn't it? Before you now do any condition, isn't it? Here, we had to get the age column from the data frame, isn't it? Before we now do our comparison, isn't it? I said, or X dollar sign gender is equals to what? F. In this case, even if you are a female, even if you are 100 years, you are going to be part of what? You are going to be part of the. Yusuf, the way you are looking at them. It's clear, huh? It's very clear.
It's very clear. You know, we need to be thinking. As we are doing this, we don't have the time to think. Once you give us time.
Okay.
Then when we go and start.
Okay, right. If I say no, it's very simple. List out all the female in the data frame.
Only female.
Yeah. That's simple.
Okay. You know, just remove that age less than 10.
List out the names going, the names of all the females.
Okay. Then, names.
Yeah? Okay, here should be name, huh? Yeah? Here, name here?
Yes.
Now.
Just think like that.
It will not work. Okay, let me just follow your instruction. Okay, like this. Then name. How will the system know a female?
I said gender.
Okay. Gender.
Names.
You have a list, and I said, Allah, print the names of all the females in this list.
You can write the name.
How can you write the name? Sorry, let's ask from online. Those online, who has the answer to this? This is very simple. Okay.
X dollar sign.
Gender, name.
After that, we add names.
Okay, I should leave gender. I say equals to F, and then here I put what? Names. Okay. Thank you very much. What's that your name? Abdullah. That will give you only the female persons. Or you can just come and say, since the name is the second column, you can put what? You can put 2. If you do this, it's clear now. Let's go back to our lecture. So we've all clearly understood this, isn't it? So filtering can also be done using the subset function, which takes the data. If you don't want to do this $sign wahala, if it's confusing you, like the way you is looking at the screen, if $sign used to confuse you, you can use the subset function. The subset function is very simple. It's a function that takes 2 parameters. Number 1 is the first parameter is the entire data frame, comma, then your condition. Is that okay? So filtering can also be done using the subset function, which takes the data frame and the condition as its what? Parameters. So in this case, you said subset. You know, in English, subset means what? Give me a part of, isn't it? You have an entire room. Let's say, please, from here to here, come outside. You are subsetting. So you can, if you don't want to use the $sign, you can use subset, isn't it? And in that case, no $sign. You just call the once you use subset, you only call the name of the vector directly. Do you understand? So for example, here, you said subset from this data frame, these guys. This will give you what? This will give you all the rows where the age is more than what? It's more than 21. So you can see, to give you all the rows, it's more than 21. And you can have multiple conditions combined using the logical and the OR operator, isn't it? Like we've seen recently, isn't it? If you have several conditions, you can join them using AND, pipe, etc. to get whatever you want, isn't it? So note that you need to specify the column name in the condition without what? If you're using subset, no, you don't need to bother yourself with any $sign, isn't it? It should give you the same thing. So there are several approaches to this. One is what we call the BISR method of indexing. As we'll come to see in our advanced class, that's what we call piping. That one we have to use an external library for doing that. It's a more elegant way of doing these things, but you have to understand this first before we now translate to others. Yes, sir. Yes, sir. Okay. If you want to print only the names, yeah, the subset. Please, it's a very good question. And if you have this kind of thinking, then it will assist you to do whatever you want to do, isn't it? If you subset a data frame, what do you get in return? You also get another data frame. So it means whatever you can do in a data frame, you can do it on the subset, isn't it? You understand? If I give you a data frame, can you access the columns? So you can also do that on the subset. Yes. So for example, if you say subset, if you copy this code, for example, and then you come to our R here. Why? Okay. Is it me or duplicate? Look at this now. If you do X, this is your entire data frame, isn't it? If you say subset X age equals to 21, isn't it? What's this? You have another data frame, isn't it? So you can as opposed to printing it, you can do it either della, isn't it? And say, okay, one name, F is equals to this guy, isn't it? You understand? F is a what? It's a data frame. And then from this data frame F, you can what? Do $sign, what? Names, and then it gives you all the names. But if you want, you can do it all together, isn't it? If you have that kind of inner thinking, isn't it? You know that, okay, the entirety of this is a what? It's a data frame. It means I can call a $sign on it. But if you have a tendency to confuse, you can just do it step by step, assign to a variable, and then do whatever. So if I were you, I would simply come here and say what? You see? I know that this is a what? This is a data frame that would only give me the rows that have what? Age more than 21. But to give me everything, but from here I can now call the $sign and then call the what? Call the names, isn't it? Names, where is it? Is it S or name, isn't it? And to give you that. But like I said, if you can get confused, just do it step by step. But you subset first, you subset, you keep it somewhere, isn't it? Maybe in H. You know that this H is a fraction of the entire data frame, but the H itself is a data frame. So it means whatever you want to do on the data frame, you can also do on it, isn't it? For example, if you call H now, if you want to get 44, what do? You can just do H. Look at this. This 1, 3, 4, 5. But this is 2. Do you understand?
Yes. Recording stopped.
So if you do H 2, comma what? 3, that's when you get what? You get 44. Don't be deceived that here is 3. Do you understand? Am I communicating? Because you subset, so it distorted the arrangement, isn't it? But as you are counting, you count the normal counting, the natural counting. This is the first row, this is the first, second row.
So what if the data is large? You still need to count.
That's why you can just use the name. Is that okay? That's why you don't need to use the index. That's why for example, this name, maybe you have 50 columns and name is the 17th column. You need to come and be counting 1, 2, 3. You can just apply in the name as the first index or second index or whatever. It's clear.
Sana kana na? Network na kana na?
My network is connected.
Okay. Ka admin ya cikin nan. Na ya tafi na shi ka admin ne.
A cikin nan.
Are you admin now? Co-host. Wa aka ma co-host?
The admin is okay. Let me finish no.
Ya kamata mu gan shi ma nan participant.
Yeah, Abba Hamza PhD.
Ya sauka.
I can't see the. Okay, the host is now somebody. Sani Musa is the host. Anyone else? I don't like saying this. Maybe I have to remove this first and put it in. Let us continue. So So as the columns of a data frame are vectors, one is an old knowledge, no? You can also use the sum, mean, median, and other vector functions on the data frame columns. For example, let's calculate the average age in our data. You can do that now, isn't it? Are you? Whenever you use dollar sign to access, what do? You get a vector, and from that vector you can apply any other function to it, isn't it? Is that okay? For example, from this you can get the column for the age, and then you can now find the mean, isn't it? And any other thing. So data frame summary operations. R data frames can also be examined using the summary function. It outputs the summary statistics for each of the columns. Like I mentioned, in practical case, the R data is usually huge. But if you want to get an immediate idea of what this data contains, isn't it? You can use a summary. For example, this our data now. X, let's assume it's plenty, and we don't know, so you can just come and say summary X, and it will give you a comprehensive details of what. So basically it's saying a column ID, there's a column name.
It's okay now, you can enter if you want.
If I want. Okay, so what's saying, we have the summary as X of X to be, we have a column for ID.
Recording in progress.
We have a column for ID, a column for name, we have a column for age, we have what? Gender, isn't it? For the ID, notice something. For every column that has numerical values, you get this statistical details here, isn't it? Like the minimum, that's a basic statistical details about the data. Okay, we have for ID we have 1, 2, 3, 4, 5. But it's telling you, yeah, this is a numeric column, and the minimum value there is 1, and then the maximum is what?
5.
Is 5, and then the first quartile, yeah, is 2. The third quartile is 4. The mean is 3. That's when you add 1 plus 2 plus 3 plus 4 plus 5 all over 5. It's going to be, and then the median, the middle value is also for the name. It's telling you that there are 5 of them, and most of them they are all characters, isn't it? And then for the age, this is the minimum. So this allows you to see a very horrid details of the data, isn't it? We also have factors. This one is trivial. Some columns are categorical. Like let's say if you have a column for names. Names can take anything now. It can be Yusuf, it can be Sadia, it can be Emma, it can be James. But you can have columns that are categorical, meaning you can fall in any of these categories. For example, gender. At least in Nigeria, there are 2 genders, isn't it? There are 2 male and female. No. I was in a meeting somewhere, and I was making an example of gender. I said male and female, and then somebody raised an objection that please, we have to recognize that there are other I had to just that I'm just honestly. It is really strange for me. I was uncomfortable then. So when you have data in categorical forms, isn't it? Either grade A, B, C, D, E, F, isn't it? That anything that comes in that column must be in that categories. Then that's when you use factors to note them. So when a data frame has a text column, R treats that column as a category. When a data frame has a text column, R treats that column as categorical data and creates factors on it. Factors are variables in R which can take on a limited number of different values, such as month names. We only have 12 of them, isn't it? Weekdays, 7 of them. So that is very useful in statistical analysis because it allows to store and treat such data correctly and use it in different models, isn't it? So for example, let's say our data frame needs a gender column, which can take one of the following two values, male and female, male or female. We can create a factor using the factor function, passing it a vector values that we need in our what? So you have a vector containing male, female, male, isn't it? If you make it a factor, you are saying that the entries for this column should be in any of the individual categories here. How many here? 2, huh? So we can have a vector that has 10 entries, but we know it can only contain either male or female. And how do you get the values in that vector? So the values are called levels, which can access them using the level. You can, so if you want to get the levels of a factor, you can just use these levels. You understand? You know a vector can contain several things, isn't it? We now said there are instances as you analyze data where the elements of a particular vector can only take predefined values, isn't it? Even though they are textual. For example, in gender, isn't it? If you have male or female, you can have 1,000 names, isn't it? But if you come to that column for gender, it can only take what? Either male or female. So if you want to comfortably treat your data as that type of format, you can simply make it a factor. Is that okay? So you can just make it a factor so that you can have this kind of distinction. If you make it a factor, it gives you the liberty to be able to invoke several things. For example, how many possible categories do I have here? And you can just use that level to get that, isn't it? So if you call levels on gender now, it tells you that, okay, it's either a male or a what? Or a female. Yes, sir.
With that question of female or male, what about if you have boys and girls? Will it work? Or man?
Yes, if you make it a factor and it has male and female, okay, and then you attempt to put anything that's not either of male or female, then it will give you an error. Do you understand?
What I said, you see in that gender factor, there's a male, there's female.
Male, female, yes.
So in the case of male,
Male,
man.
Man,
In the case of female, woman. This works.
To work. To work.
After the start male, I can see
double bracket, yes. The first one.
Down, gender. I can see factor, C, bracket,
Yes.
down here.
Down here, okay.
Then bracket, what I want to then double bracket there. Then at the end of it, also another double bracket. What does that mean?
This C is a function.
Yes.
This C is a function.
Okay.
And in function, we learned that any function, whenever you call any function in R, what do you do first? As soon as you call it, you have an opening bracket and then a closing bracket, isn't it? And then whatever parameters you have in the function inside it, right? So we have here, we have C, which is a function. Eh? This is a function. So this is the opening bracket for this C, and then this is the closing bracket for this C. And then the factor itself is another function. So it should also have its own opening bracket and closing bracket. And what we put inside it is that C vector. That's why we have closing bracket. So each value in a factor has its corresponding number. We can check them out using the table function. So there's a function called table that helps you check the number of what? Of each factor, isn't it? You said the levels will tell you the levels, but how many are they, isn't it? And then the table will give you the number, isn't it? And usually it arranges the levels in alphabetical order, isn't it? And then assigns the number, isn't it? For example, if you have male and female, if you call the table, it will tell you that the first number is what? Is female, and the second number is male. Why? Because in the alphabetical order, F comes before what? F comes before M, isn't it? So in this case, now we can assign our factor to a new column in our what? In our data frame. So for example, we have this. We have a data frame here that has ID, that has names, that have age. Is that okay? And then we want to add a new column. Isn't it? So we have gender is what? We have a new variable, a new vector. Sorry, a new factor, isn't it? Which is male, female, male, isn't it? And then we can now come and add that factor to the what? To the data frame, isn't it? And then we can now see male, female, male. Is that okay? So this brings us to the end of week 2. We are going to end. If you have questions, let's do it. Then we enter week 3 now and just start it. Okay. Okay. So we are done with week 2. Tomorrow I have a wedding to attend. I may not be able to make it. Sorry, it's a wedding I cannot afford to miss.
So maybe what we are going to do, we look at how maybe during the week we can fix a class.
Sunday, yeah, Sunday 2 to 4.
Sorry, what we are going to do, maybe during the week we might look at the possibility, then we'll fix a class, we'll communicate through the platform, everything possible. So that by the time I can.
Virtual during the weekday.
Yes, ma'am. Okay, let me illustrate it.
I think I see Nasa Martin. Yeah, breaking network. So I got a 7 a desktop naka.
Okay, good.
Say, I 7 naka nake nasa desktop sana kara. Amma ka riga ni 7. Sana ci gaba. Yanzu na biyu.
I should stop recording.
Yes, you can. Ba akwai wani tambayar da zaka fara gaba.
No. If you want, stop it already. Look at this. If I run this, I call X now. Doc, this is it. I have a data frame that has 3 columns, isn't it? The first one is what? ID, name, and age, isn't it? if I want to have a column now for gender, I can simply do it as a vector, isn't it? And say I have a gender that is a vector containing what? Anas is a male. And the second one is what? Is also a male. The third one is also a female. The fourth one is a male, and then the fifth one is a male, isn't it? I can just come and add this particular anyway, before I come to the data frame, isn't it? You see, look at this. We have male, female, female, male, female, isn't it? This is a vector. But if we want this column to only, if we want R to see this column as only being possible, the English is going. If we want R to know that this particular column for gender or this vector can only take two values, male and female, then we need to assign that it's going to be a factor. So in that case, we can just say gender. We can just say gender is equals to what? Factor. Factor what? Gender. So here I'm converting this gender, which was earlier a what? A vector to a factor, isn't it? Why is this useful? Very good. Why is this useful? It's just a way of telling R that okay, this particular set of numbers have two possible states. And how do we get that? We say levels, go. We say levels for what? For gender. And we see what? Male and female. It means these are the two possible values that can come into this particular. If I come here and I say gender dollar, let me say this 1, 2, 3. Let me, in vector. Okay, let me say gender 3. Is equals to gender 3 is equals to, let's say, female. What happens? What happens? You get it? I'm saying, okay, before I do that, let me just come here and say, this is gender. Gender has what? Male, male, female, male, male, isn't it? If I want to say, okay, gender, this third one, she is not a female, she's a male, for example. Or maybe let me say this number 3. I want to make it to be female, but instead of putting F, I put female. What happens? I don't get any error. But if I invoke it now, what do I have? I have male, male, female, male, male. Even though semantically it makes sense for a female to write female, but if you are analyzing data and you don't want any confusion, so that somebody will put F, somebody will put female, somebody will put FM, or somebody will put male with small letters, if you want to make it to be consistent, then if you convert to a factor, then you are saying you can either make it this or that or nothing else. Do you understand? So we simply made female to be FEMALE, and it gave us no error because it's a vector, and a vector can contain anything, isn't it? But if I had earlier made this to be a factor, look at it. So I have a vector here, isn't it? Containing male, male, female, male, male. And I'm now saying, I know you are a vector, but convert me to a what? To a factor. So if you do this now, if you call the gender, you see that it's the male, male, female, male, male, but it's telling you it has two levels. You can either be an F or you can be a male. Even if you attempt to do something like this, you know, if I come and put F now, what happens? It gives no error, isn't it? If I call the gender, it says it is what? M, M, F, M, M. If I want to convert that F to M, I can just come and say what? M, isn't it? Yeah? I can even add a fifth entry, isn't it? This 1, 2, 3, 4, 5. Let's say a sixth entry, isn't it? That's 6, go. And I make this one to be what? To be F. If you call gender now, you have MMF, MMF, isn't it? So it means in this particular factor, you only have the chance to either put any of these two levels, either a female or a male. I can come here and say, okay, 7 is another female, 8 is another. Why is it accepting? Because the levels says you can either be an M or an F. If somebody comes and I ask her, what's your gender? And she says she is the 9th person and her gender is what? Is female. Anyway, there's nothing wrong here, isn't it? But because I have declared my gender to be a factor, it will give me error. And that will force her to put F. So that if you're analyzing your data, what's the problem with this? If this were to be a factor, it will accept both F, both M, both male, both female. And let's say you are a data analyst of your company and he says, I want to see a pie chart that shows the distribution of the male and the female. Maybe if there are 100 of them and there are 70 male and 30 female, I should just be a simple pie chart, right? 70% male and 30% female. But if you allow your column to contain both male, female, F and M, if you do a pie chart, it will tell you it is 40% female, 30% male, 20% F, 30% M, which doesn't make sense, isn't it? So the only way to avoid that is to make your column to be a what? A factor. You are telling her that under those circumstances should you accept anything outside of these two levels. Is that clear? So continue from here.
So is it that factor and levels are set only on categorical data, categorical variables?
Yes.
You want to?
Yes.
What if it is 3?
Or what
It will not take. If it is 4, for example.
If it is 4, yeah, it should accept it, man. So you have 4 levels. One, for example, scores. You can have A, B, C, D, E, F. For example, if I come to this place and I add K, what happens? But in this case, I have how many levels? I have 3 levels: F, M, and what? K.
Recording stopped.
Yeah. Disconnect. Disconnect everything.
You want to? Okay. Okay. This is your X. This is